All right, welcome back. Last time we looked at the what? At the numeric codes, and specifically the what? The weighted codes. All right, we looked at quite a few examples. Now we're going to look at what? Numeric codes still, but the ones that are non-weighted. Let's take an example with excess3. Let me write it full. In full, it will be excessive 3. It is still a binary coded decimal, so it's a decimal that would at first sight give you the impression it was what? It was a binary. Now let's look at the decimal symbols. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now for them to be excessive 3, you have to add 3 to each and every one of them. You have to add 3 to each and every one of them. So 0 plus 3 becomes 4. 4 in 8, 4, 2, 1. So what do you do? 8, 4, 2, 1, 4, extra 3. Okay. So now, extra 3 is 3. 8, 4, 2, 1, 4, 8 is what? No 8, no 4, 2, and 1. For 1, extra 3 is going to be 4. That will be no 8, a 4, no 2, no 1. For 2, if you add 3, that will be 5, that will be 4 and 1. For 3, that will be 6, that will be 4 and 2. For 7, that will be extra 3, that will be what? That will be 7, 4, 2, 1. For 5, with an extra 3, that will be 8, it's an 8, no 4, no 2, no 1. For 6 is 9, it's 8 and 1. For 7 is 10, it's 8 and 2. For 8 is 11, 8 and 2, that's 10 and 1. And that one is 12, that is 8 and what? And 4. So, suppose we had a number 137 and we want to give it as what? As 8421. We ask for 8421 BCD. What will that number be? It will be, for the 1 is the same as what would have been in 4 in 8421. So 1 would be 4. Okay. 3 would be 2 and 1. No. 1 is 4, yes. But 3 is 6, which is 4 and 2. 7 is 10, 7 plus 3. So you are adding 3 to each and every one. So this here is the first 4 here is what? Is 84214, 1 plus 3. This next one there is what? Is 3 plus 3. The last one there is what? Is 7 plus 3. So each decimal digit is as a 3 added to it. So this is going to be what? This is the equivalent of 10. 841 is what? 8 and 2. All right. And then this is what? Oh, I'm making a big mistake. I've been working on XS3. So my mind is on XS3. I didn't ask for XS3 here. I asked for 8421. So let's have XS3 here. This is what it would have been as XS3. I've been doing XS3, so I'm adding 3s there. Got carried away a little bit. This is XS3. For 8421, that there would have been a simple 1. No 8, no 4, no 2, just a 1. And then the 3 would have been no 8, no 4, 2 and 1. And the 7 would have been no 8, a 4, a 2, and a 1. And this here would be 8421 BCD. That there where you add extra 3s, that would have been XS3 BCD. Okay, so I got carried away. I asked for 841, but because I've been working with XS3, my mind was probably locked onto XS3 mode. Now let's just say, what could this have been with 2421? I intend that to be an arrow. Okay, 2421. All these are BCD. Remember, BCD, BCD. Okay, now 2421 for 1 would have been just 1 for the 1. The 3 would have been lower order 2 and the 1. The 7 would have been higher order 2, the 4 and the 1. And together that will be 2421 BCD. So I'm just bringing up the old work so that you can we can actually relate and see how things are actually operating here. Alright, so what we are busy with here is XS3, and all you do is each decimal digit is going to be extracted with what? It's going to be represented by what? An extra 3. Alright, each decimal digit is going to be represented by an extra 3. So if you look now at this chord, 4 and 5 are actually 9's complements of each other. Are these two the code words? This is S, this is 9 minus S. If this is S, this is 9 minus 4 is 5, this is 9 minus S. Are these two ones complement of each other? Yes. So these two are 9's complement. Those two are 9's complement. 3 plus 6 is 9. Those two are 9's complement. Oh, what am I doing? It's because my 3 and 6 is not doing justice. So that one is 2 and 7, that one is 1 and 8, and lastly that's what? 0 and 9. All these are what? 9's complement of each other. Okay, 9's complement of each other. Now that there is 1's complement, so 4 and 5 are giving 1's complement of each other. 3 and 6 are giving 0 double 1 0, 1 double 0, so this is 1's complement of each other. 2 and 7 are giving us 0 1 0 1 and 7 1 0 1 0, so this is what? 1's complement of each other. And then 1 and 8 is 0 100, 1 0 double, they are 1's complement of each other if you look at it. And then the other one is double 1 double 0, that one is 0, so they are 1's complement of each other. So each pair that was 9's complement of each other is also giving us what? 1's complement of each other. So this is a what? A self-complementing chord. So the excessive 3 is self-complementing, but non-weighted. So if you ask for an example of a chord that is self-complementing but non-weighted, you've got your XS3. So if you look now, if I have, what weights are here? If I can say 2 and 1, it doesn't give me 0. So this is not, if I pick a random example, if I say 8 there, it doesn't give me 5. So these numbers sitting in a specific position don't necessarily carry a what? A weight. So this is what? This is a non-weighted chord, but it is what? It is self-complementing, as we've what? As we've proven. This side there is 1's complement of each other. So if every pair that is 9's complement of each other is actually what? The chord words are actually 1's complements of each other, and that is how we define our what? Our self-complementing chord. Now the other chord that I would like to look at, okay, how do we go back? If we are given a number, let's say we are given 0 1 1 0 1 0 0 1 0 1 0 0, and we are told this is 8421, and we are asked to convert this to what? To 2421. I'm making an example here. 2421. We are told that this is 8421 BCD, not BTC, BCD, and we ask for 2421 BCD. What do? These are decimals, so we first have to know what the decimal is. If you look at this, we know every 4 bits give us a what? We'll take the number as it is, 0110 1001 0100, and we know this is 8421, so this is going to be 8421. 8421. 8421. So when you read this off, this is going to be 4 and 2, 6. This is going to be 8 and 1, 9. This is going to be only 4. So this number is actually 694. In what? In decimal, in our normal what? Decimal. If you are then asked now to say, okay, we are asked to make it that, so we need to first take it to what? To decimal. Because we need to know what the decimal is to interpret it as what? As 2421. Now we can say 2, not the big 2, but the 4, yes, the 2. No. 2421. This is higher than 5, so yes, that 2. The 4, not the smaller 2, not the 1. 2 and 4, 6. The 9 is everything, 2, 4, 2, and 1. The 4 is the 4 itself. Okay, so this here is what it would be in 2421. I'm putting this to indicate which code it is, because it could have been a decimal number. All right, there is a number in decimal that is billions, 100 and something billions, and it's all ones. So to differentiate, we actually indicate what language we're actually using. All right, so this is what, this is how, I don't know, I've done the excessive 3, I've done the what. Now let's suppose that, because our work here was what? Was convert that to 2421. Let's say you had been told to also do it in what? In excessive 3. Okay, you would have said you still need, oh, I didn't bracket this, you still need to convert it to decimal, because excessive 3 is also a what? A binary coded decimal. So it's a decimal. So you would have first needed to do decimal, then you would have come and say, okay, but for the 6 I need extra 3. For the 9 I need extra 3. And for the what? For the 4 I need extra 3. And then I have to do 8421 for each. So this here would have been 9. That would have been 12. I don't want 1, 2. I want 12 as one number. And that would have been a 7. Then I have to do 8421 for each. And our answer therefore would have been 8 and 1 with 8 and 4 with no 8, a 4, 2 and a 1. And this here is what? Excessive 3. And I would indicate, because look, they all look like with ones and zeros. So for you have to state which one it is. You have to indicate which one it is. You have to indicate which one it is, because they all look like ones, a bunch of ones and zeros. So unless you say what it is, it can be very misleading. So you have to indicate. Just like with binary, you have to put the letter 2. You have to indicate which code you're actually working with. So if we are given, this is one situation where we are given what? Where we are given, let me rather remove this. I think we are all on the same page here. We understand what excessive 3 is. We know what our other codes are. And now we probably have, what am I doing there? If I delete this, everything going? I didn't think so. Oh, what is going on? I'm supposed to do this in one sweep. Ha! Something is not on. Okay, anyway, so much time wasted for nothing. Let's now say, okay, we are given a number and we're asked 1, that's right, 1 0 1 1 0 1 0. Let's say 1 0 1 0, and we are told this is excess 3, and we are asked to convert this to, it's a BCD. We have to convert this to, let's say, 4221 BCD. I am making it, I'm deliberately making the conversions between two different codes, because we're dealing with codes here. All right, so if I have to convert this to, you could have been asked to convert it to a normal decimal number. You could be asked to convert it to binary, but key is you have to first know what the decimal is. All right. So what do? You come and you say, okay, we know every set. What? This one here, 4 bits will give us what? 1 digit. Another 4 bits will give us. I'm starting from there because if there was commas, let's say this number had commas. Let me rather, to make it interesting, let me rather put commas. Let's say this was comma 1, a simple one. Let's say it was comma 1. Then you would say, okay, it's 1 0 double 1 0 double 1 0. It is what? 1 0 1 0 1 0 comma 1. And you know that, why am I doing this? I want you to know that the counting starts from the comma, 4 bits, the other 4 bits, the other 4 bits. Now this needs to be 4 bits as well, so we have to add by putting zeros in front of a what? In front of a comma, in front of a number after a comma does not change, does not alter the value. So this is done, we have done nothing wrong. So then what we do 8421 for each, 8421 for that, 8421 for that, 8421 for this, 8421 for that. This here gives us an 8. If we didn't put zeros here, it would have looked like a 1. It's actually an 8. The comma stays in place. That there is 8 and 2, that's 10. That's 10. Remember, this is excess 3. So that there is 10. Okay. That there is 6. That there is what? Is 8. That's 11. Okay. We know that this is all these carry an extra 3, so we remove those 3s to know what the decimal is. So we remove the 3s. All right. So this here will remain as an 8. This here will go to what? To 3. That there will go to 7. The comma stays, and that there is now 5. What you then do, because this is our decimal, all right, we need to then change our decimal to what? To 8421, to 4221 PCT. Now we know that this one here must be 4221. This must be 4221. This must be 4221. And that must be 4221. So we know our comma stays there. But this here is what? This is 5. It's the 2 2s. Remember? It's the 2 2s and the 1. Alright? That there is what? Is the higher order 2. It is 1 1 0 1. That's 6 and 1. That one there is what? 3. Is the lower order 2, is that less than 5, so 2 and 1. And that one there is 8, which is all 3 with a 0, right? And this here we must indicate it's not binary, it is not decimal. We have a number like this in decimal, it is not binary. This is what? This is, it could have been octal, it could have been anything, it could be hexadecimal, but it is not. So we have to indicate this is what? 4221 BCD. Okay, so I believe I've made enough examples for people to be flexible with this. You can play it over and over. If you have a problem, I don't think this is the most difficult work we would do. Let's suppose you are given a number random and say 1 0 1 0 0 0 0 0 1 0. No. Let me put this as 0. I'm seeing a problem coming. 1 0 0 3 4 zeros and 1 0 0 1. And the question says, if you are told this is either what? This is either 2 4 2 1. This you are told is this 2 4 2 1 BCD, or excessive 3, and then they say give a reason. We're told it's one of the two, but now which one do you think it is, and give a reason. Now if you look at this, if it's excessive 3, that will be 8, that will be 0, that will be 9. That's possible in excess 3, that will be 5. That's possible in excess 3, that will be 6. 6 plus 3 is 9, but you don't have a 0 in what? In exercise is 3. The minimum there is 0, 0, 1, 1. Okay, so what do you then do? You then say, no, this can't be exercise 3. Can it be 2, 4, 2, 1? 2. Okay, 2, 4, 2, 1. This would have been 2. Ne? So that would have been 0. That would have been 2, 3. And we know, nope, that's not possible. If it was 2, it would have to be the lower order 2. If it was 3, it would have to be the lower order 3. So it is, your answer is, it is neither. Okay, it is neither of them. Why? The 2 would have been a lower order 2 for exercise 3. You don't have a 0. First reason is it can't be exercise 3 because you don't have 0, 0, 0 in exercise 3. Minimum is 0, 0, double 1. And then it can't be exercise 3, what call this? Can't be 2, 4, 2, 1 either. Why? That suggested 2, but the 2 would have to be a lower order 2. And that suggested 3, and it also have to be, for the same reason, it can't be that as well. So if you asked, maybe you were given a third option, maybe this was not O. If this was not O, if it was 8, 4, 2, 1, B, C, D, O, then you could say yes, in 8, 4, 2, 1, that would have been 8, 4, the thing 809, and yes, as 809, and I said in decimal. Okay, so questions can check for understanding. They don't always ask you to convert things from this to that. They can ask you in different ways where you need to apply your knowledge. So I hope this was clear. I don't want to tackle. I don't want to tackle the gray code with this. It's going to what? It's going to. So I'm going to come back with the numeric code. I'm going to look at the gray code. I don't want to necessarily crowd our work. I think this has been long enough. I hope it was engaging. I hope people are happy. I know I am happy. So ciao. I will see you later.